How do you find the surface area of a prism? We're going to go ahead and answer that question in this video. And this is the first video for section 11-2 out of our textbooks. Here's a reminder of how your notes should be set up to take notes from this video. Okay, let's go ahead and begin with a vocabulary term. Prism is just a polyhedron with two parallel congruent bases and is named after its bases. So for this example, the triangles are actually the bases. So sometimes your shape could be laying down like this shape, like this polyhedron here, but it still will have the triangles be the bases and called a triangular prism. Surface area is the sum of the area of each face of the solid. Remember on Friday in class, we deconstructed or gave the net figure of a rectangular prism, and we calculated the area of each rectangle, and we were able to add up all those areas, find the sum, and that would give us the total area of the rectangular prism. That is what we're doing for the next two videos, is we are looking at the different areas of these prisms, and then we're finding the area of those prisms and adding it all together. So there are some specific formulas that you might see in your textbook, but we will definitely discuss our method of just finding the area of each shape and combining that to give us the total surface area of the polyhedron. Okay, just a reminder of how you can reference the different areas of a prism. We would have the top, and then of course the back is in the back. This is the front. Down here would be the bottom, and this would be the right and the left. Okay, I'll use those terms to describe which sides we're looking at. For this video, we're going to discuss and focus on types of prisms. So for there's different types of prisms, and remember that usually the shape that is on either side of the prism is described as the bases and also helps you figure out the name of the prism. So for this one, the base is a pentagon, so this is a pentagonal prism. These are called lateral faces or lateral edges. Lateral is just for another term of either a vertical or slanted or like an outside edge, okay, outside face. And this is also called, like for this example, a triangle is the base. It would be a triangular prism. This is what we call a right prism. Notice all the right triangles in there because it is a rectangular prism. And this would be an oblique prism. Okay, notice this parallelograms, so we would call that an oblique prism here. You definitely want to pause the video and write everything you see on the slide and then resume when you're ready to follow along with me. There's some formulas you're gonna need to remember, and I just want to remind you that within geometry, or within math, not even just geometry, within math, it's not that you learn something and you forget it and you never apply it again. We have been discussing for a while now area of simple shapes and figures and polygons, and this is why we need to know that, because there's some of these formulas we need to use to help us find the surface area of polyhedrons. So the area of a triangle is base times height divided by 2, or 1/2 base times height. An area of a parallelogram is base times height. A parallelogram includes rectangles and squares and rhombuses. Area of a trapezoid is the height multiplied by base 1 plus base 2 and divide your answer by 2, or it's 1/2 times all this. And then remember the area of a regular polygon was the apothem multiplied by the perimeter of the shape, and we divide that by 2. So what happens if you have a prism with the bases of a hexagon or pentagon? You would have to use the area of the regular polygons to help you find the area or the surface area of that prism. Okay, let's take a look at a surface area of a right prism. So remember, oblique is where it's kind of slanted and leaning to the side, but these are right prisms. Remember, we discussed that really it's just the area of the base of one of the bases, and then multiply that by 2 to get area of both bases, and then area of all the different sides that make up that prism. So this is 3 rectangles and 2 triangles, so you can find the area of the 2 triangles and the areas of the 3 rectangles. Or if you're looking more into your textbook for help and support, you may see this formula: surface area equals 2 multiplied by the area of one of the bases plus the perimeter multiplied by the height. So this is also another way to get the surface area of a prism. Remember, if you forget this formula or you don't have it with you, if you find the area of a triangle, multiply that by 2, and then find the 3 areas of the rectangles and add that all together, you would get the total surface area. B, in terms of this equation here given, is area of one of the bases, and then you multiply that by 2, just like I've spoke before. And then to find the area of the rest, you really just have to find the perimeter of one of the bases, and then multiply that by the height of the prism. So perimeter would be adding up of these 3 sides, and then multiplying it by that height. And then adding that to 2 times the area of one of the bases would give you the total surface area of a right prism. This is how your book labels the surface area of a prism. I'm not going to go through and discuss it too much. I did explain each part, but if you look at this part of the formula here, is exactly what we just had on the last page. So this lateral area, okay, that's the area of one of these sides, like this side here, like on the right side. Lateral area is perimeter of the base multiplied by the height that goes in here. So the formula that you saw was this on the previous slide. Surface area equals 2b plus p multiplied by h. Same exact thing. So I just didn't want you to see it in your textbook and be confused. Now that we have the formula, let's practice some examples. Let's find the surface area of this right solid here. This is a right prism. We're going to use the formula that's given to us, which is 2 multiplied by the area of the base plus the perimeter multiplied by the height. Over here is the side work. Let's first find the area of this base here, this dark blue. It's base times height for a rectangle, which is 5 times 6, and that's 30. So that goes in for our formula here for large B. The perimeter is going to be 5 plus 5 plus 6 plus 6. And when you add that all together, you get 22. And that goes here. And then the height of this solid is 7. So we plug that in here. Then we multiply and get 60. Multiply to get 154. Add those two together and we get 214 meters squared. Now, if you want, you can find the area, the bottom area, and then multiply that to get the area of the top two. Get the area of the back and the front. Get the areas of the 2 sides. Add that all together and you would get the same exact number. Here is example number 2. So we put EX2. We need to find the surface area of this prism. And notice that this is a 1, 2, 3, 4, 5, 6 sided. So this is a hexagonal prism. Oh, it's right there. I didn't even see that. Hexagonal prism. So we're going to use this formula. The surface area equals the lateral area plus 2 times the base. Remember, the lateral area is just P, the perimeter, multiplied by the height. So we're going to go ahead and take a look. Now, notice they had to take a little triangle out. That's from here because we need to find this apothem in order to use the formula A equals 1/2 A multiplied by P, or AP divided by 2. They went ahead and did 360 divided by 6. Then they took that and divided that by 2, and they gave us 30. And then this was already given, right? We already told that this is 6. So half of that was 3 for the little triangle in there. And then they use special right triangles to find out the apothem. And so now to find the area, they take the perimeter of this shape, which is 6 times 6, and that's 36. A is 3 radical 3 that goes here, and multiply that by 1/2. And that will give you the area of the base, which is 93.5 right here. And then 93.5, we'll multiply that by 2 because we have the front that's a hexagon, the back that's a hexagon. Notice that we don't have to do that twice, which is nice. And then the lateral area, that is the perimeter, the 36, and then multiplied by the height of this shape. The height of this shape would be double, it would be 36 the perimeter and multiplied by 12, the height of the shape. Remember, this is on its side, so the height is right there, which is 12. And so 12 times 36 is 432. And we plug that in here. And then we add those two together and we get 619. So if for some reason you're confused, go ahead and pause the video and replay this section as I explain it. Make sure you might want to add some extra notes in there, some things that you didn't understand or didn't know before. And bring any questions you have to class. Okay, here is example number 3. We're going to find the surface area of this right solid. So once again, it does come down to, you're going to need the perimeter of this triangle. So we do need to know what this side is here. This C side is here. This side right here, this hypotenuse. And we'll need to find the area of this triangle. So the first thing is we'll find the area of the triangle. 1/2 base times height. This is base. This is the height of the triangle. We get 12 times 5, and then that's going to equal 30. So that goes into our formula here. Then I need to find the perimeter of the shape, and to do that, I need to know the hypotenuse. So I have to use Pythagoras' theorem because this is a right triangle here. And I do a squared plus b squared equals c squared. I find out that c is actually 13, which is great. So c equals 13. And then I'll add up all those sides to get that p equals 30. So that goes in right here. And I multiply that by the height, which is 10 of this shape, which is right here. And then I will, because remember, this would be the height if this was on the right side. Then I add those two numbers together, and I get 360 centimeters squared for the area, surface area, excuse me. Okay, I'd like you to try this example on your own, and we will practice this one in class, so bring your work. And now we have discussed how do you find the surface area of a prism. I would like you to now answer the question of how do you find the surface area of the prism. I gave you multiple ways to do it. Recapping back, we looked at how to do it logically just by finding the area of all the shapes and adding that together. But that formula changes on the shapes, right? And then we also discussed that there are 2 formulas you could use. One that includes the lateral area already in the formula, and one that does not include the lateral area, so you have to find it and then make sure you plug it in. So go ahead and recap your notes, look at some examples, practice them on your own, write down your summary in 3 to 4 sentences in length, and bring any questions you have to class.